Well, here we go, guys. This will be the last example we're going to enjoy together this whole semester. Can you believe it? This is it. This is our last one, which is sort of a bittersweet moment here. And Mr. Sandpaper's really going to miss you guys. We've been through so much together. Any of you feeling the emotion of the moment? Yeah, here, if you'd like a Kleenex. Here. Oh, yeah, you want one? Okay. Yeah, I know, me too. I can't believe this is it. Okay, so we're still with example 2. I want to remind you that we just did a hypothesis test, and the conclusion of which was there is indeed a linear relationship between these two variables. So it does indeed make sense to make the equation of the regression line, doesn't it? And lines are y equals slope x plus y-intercept. And again, there's that discrepancy between the algebra nerds of the world and the statisticians of the world as to the labels to use here. So I want to remind you in stats, the slope is called b, and here is its formula. So b in stats goes right here, it's your slope. And as we mentioned on the previous example, woohoo! The numerator of b is the same as the numerator of r, and it sure be cool if we saved that numerator of r. Yes, we did! 1235. Cool. Good idea. 1235. Look at the formulas. The denominator of b, this is all from that table we made a long time ago, but the denominator of b is the same as that first bracket when we did r. First bracket, 6508. And then if you divide that out, that comes out to be 0.1898. That is a positive number. That corresponds to the idea of a positively sloped line, going back to that picture. All right? A, which in statistics is your y-intercept. I'll point out again that the denominator of A is the same as the denominator of B. All right? So, aren't they? Yeah? Yep, okay. So 6508. But this is where we have to go back and build the numerator by scratch. So I would again tell you to go back to that table that we made when we did example 2. And let's see, the sum of y on that table was 62. And the sum of x squared, let's see, what color was that column? Yep, blue, yep. 53,219. Please fit. All right, minus sum of x, what was that one? Yep, 605. I hope I'm looking at the right table here. 605. Well, I'm sorry, I should have planned better for space here. Sum of xy, what color is that column? Yeah, red. That's right. 5535. I'm really sorry, I didn't think ahead very well. 5535. Boom, 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 boom. Crunch, crunch, crunch. Okay. And so you do the arithmetic on that one, and it comes out to be negative 7.5441. So instead of plus negative, let's just call that minus 7.5441. Boom. Okay. So there's our equation of our regression line. It would be our prediction. And so here's the point of this whole thing. If you were the manager of this emergency tow truck agency, or whatever you want to call them, you would have your prediction equation. And so let's say on a particular day, you wake up and it says, hey, it's going to be 60 degrees today. You would then put 60 in for x. I want to remind you that x is the outdoor temperature. We assumed Fahrenheit. Probably should have specified that. But anyway, you put 60 in, you crunch the numbers over there, and your prediction equation would come out to be 3.8439. But this is one of the things that's a little different about this question as well. I want to remind you that back a long time ago at the beginning of the question, it said number of emergency calls in hundreds. I'm pretty Pretty sure number 2 on homework has a similar idea. All right, so you're not going to say 3 emergency calls. You're going to say this number in hundreds. So to me, it would make sense to take that number times 100, which is about 384, but I'd go ahead and round up. And I'd say, okay, I would expect 385 emergency calls that particular day. I will tell you that example 2 that you're doing, or homework problem number 2, has a similar idea as far as that being in hundreds. I think yours is thousands, okay? So make sure to make that adjustment there. And there's the deal. Now, last thing. We're done. You can quit watching, I guess. But I'll just throw this out there for discussion because I think it's I like to end with this one. You know, if your slope is -7.5, that would be down here. Let me get that R value out of the way. If you extended that y-axis on down to -7.5, which I'm just eyeballing, so your intercept would start here, and then you'd slope up about 0.2, rise 0.2 over 1, and so on, and keep going. And you would eventually, from that y-intercept, run through those data points. But here's the thing that I guess I would just throw out there. So you're telling me, according to this model, if the temperature was 0 degrees, you're going to have about -750 emergency calls. How could you have a negative number of emergency calls? This is a good exercise in talking about the fact that the original data, the original temperatures, really only were, I would just say that that's only a good model for temperatures, let's say, from 60 and above. And so we're overgeneralizing if we were to come back here to 0 degrees, or 10 degrees, or 20 degrees. See, these temperatures back here wouldn't fit that model very well, probably, would they? And so you have to be careful not to overgeneralize. See, that data only represented certain types of temperatures. I would be willing to bet that if we were to gather information for when it's cold outside, we might have had something like this. And we would have had a line that looked like that. And so there would be a couple of options a person could do. You could either build one equation for temperatures above, I don't know, say 50, and a different one for temperatures below 50. Or you could build one equation, a curvilinear, as they call it, for all temperatures. But you wouldn't probably want to use this mathematical model for every temperature because the data collected did not represent cold temperatures, did it? Okay, so that's the end of that. It's been a pleasure this semester with you. I definitely miss you. Don't worry, I'm not going to sing you a song to end it with. I just want to simply say good luck to every one of you. I wish you all the best and thank you for all your hard work. Maybe I'll see some of you in calculus. Who knows? Sodergren out.